As I've said in every other section, this is an important section. You're going to have a problem guaranteed on the ACT in this section. You can see why geometry makes up like 50% of the ACT. So you do well in geometry. Yep. But SOHCAHTOA, sine, cosine, tangent. It sounds like foreign words that you've never heard before, or maybe you've heard them and always wondered what they meant. It's really easy. It's just remembering, okay? So here is a triangle. Let's do A, B, and C. This is B, and A, and little c. Remember, the small letters always correspond to the side opposite the angle. So capital A corresponds to little a opposite, and capital B is little a, little b opposite, and capital C, little c opposite. Okay, so sine, cosine, tangent. And the words are actually sine, cosine, tangent. Okay, but it's always abbreviated with 3 letters. So sine is S-I-N, but it's not pronounced sin. This represents sine. So when you see this, say sine. Don't say sin. Okay? When you see C-O-S, it's not cos, it's cosine. And T-A-N, it's not tan, it's tangent. Okay, those represent sine, cosine, tangent. Okay? So to find the sine of an angle, let's call this angle A. Sine, that's so how I say this is sine of angle A. Sine is equal to the opposite of A, which is little a, over the hypotenuse. Opposite over hypotenuse is sine. Cosine of angle A is adjacent over hypotenuse. Adjacent means the side closest to the angle, not the opposite. The adjacent will never be the hypotenuse. The hypotenuse is by itself on its own. So when you're dealing with opposite and adjacent, you're only talking about the legs of the right triangle. So it's either opposite the angle or it's next to the angle. But it's just the legs, it's not the hypotenuse. So the leg adjacent to angle A is leg B. So everybody see that? It would never be leg C because C is the hypotenuse. So when I'm dealing with opposite and adjacent, I'm only talking about the legs of the right triangle. Okay? So adjacent to A is B, hypotenuse is C. So that's what cosine of A is. Tangent of A is opposite over adjacent. And opposite is A, adjacent is B. And there's a nice acronym that helps you remember all of this. And you pronounce it SOHCAHTOA. Sometimes I think about soaking my toe. SOHCAHTOA. That's how you pronounce it. And this is how you spell it. So is S-O-H. Ka is opposite, no, adjacent, sorry. Ka is C-A-H. Toa, T-O-A. SOHCAHTOA. SOHCAHTOA. This is your acronym to help you remember what sine, cosine, and tangent are. S in the acronym stands for sine. So this is sine. Sine is opposite over hypotenuse. Opposite, hypotenuse. Cosine is adjacent over hypotenuse, AH. Adjacent, hypotenuse. Tangent Opposite over adjacent. SOHCAHTOA. If you remember the acronym, it will help you remember what sine, cosine, tangent are. You do it enough, you don't need the acronym anymore. But initially you might. So it wouldn't hurt on a quiz or whatever just to write SOHCAHTOA at the top so you remember what's what. Okay? So how we use this, I know 3, 4, 5 is a triple, so I know those are good values that would make this a right triangle. If I want to find sine of A, well, SOHCAHTOA, so OH tells me it's opposite of A over the hypotenuse. So sine of A is 4/5. Sine of B then, opposite over hypotenuse, 3/5. Cosine A, adjacent, CAH, C-A-H, adjacent over hypotenuse. Adjacent to A is 3, hypotenuse is 5, cosine B. Notice how the sine of B is the same as the cosine of A. The sine of A is the same as cosine B. And then tangent of A is opposite over adjacent. Tangent B is adjacent over, or opposite over adjacent from B. So that's sine, cosine, tangent. Okay? Some things in the textbook they talked about that are good to remember. Always reduce your ratios when you can. So if you end up getting 6/10, make sure you're writing it as 3/5. Use the Pythagorean theorem to find the missing side before you even start. So if they don't give you it's 3, 4, 5, they give you 2 sides and you don't know the third, just use Pythagorean theorem and find the third, and then you can write your ratios. The tangent ratio can be bigger than 1. Here, the tangent ratio was bigger than 1, right? It's possible. It's not always bigger than 1, but it's possible. Sine and cosine can never be bigger than 1. Why? Why? It has to do with the hypotenuse. They both have the hypotenuse in the denominator, and the hypotenuse is always the longest side of a right triangle, right? So if I have the longest side in the denominator, I could never have a longer side in the numerator to make it greater than 1. It's always going to be smaller in the numerator than it is the denominator. So it can never be greater than 1. Sine and cosine. If you get sine or cosine greater than 1, you know you've done something wrong. Can't happen. Tangent's possible, not always. If 2 right triangles are similar, then their sine, cosine, tangent are identical. You find the sine, cosine, tangent of one is the same as the sine, cosine, tangent of the other. You may just have to reduce your fractions. If there's a radical in the denominator, you must rationalize it. We learned how to do that last section. And the sine, cosine, and tangent for an angle are fixed. If I asked you what the sine of 30 was, let's just look at that. If I tell you this is 30 degrees, what's this? 60. How could I label this triangle with real numbers instead of x? What goes where? Use the smallest numbers you can think of that are integers. Opposite the 30 is 1. Hypotenuse is 2. This is the square root of 3, right? That's how I would label it without x, just with numbers. And remember, that's how I remember it. 1, 2, square root of 3. Then I just place them where they need to go. Okay, what's the sine of 30 degrees? Sine is opposite over hypotenuse. Sine of 30 is 1/2. And it doesn't matter the triangle. If the triangle has 30 degrees in it, the sine of 30 will always be 1/2. Sine, cosine, and tangent are always fixed. They don't change. Sine of 30 will always be 1/2. Cosine of 30, square root of 3 over 2. adjacent over hypotenuse. Okay, and they're always fixed. Okay, 3 more terms that are related to sine, cosine, and tangent. All you need to do is find sine, cosine, and tangent, and you can find the other 3 without doing any more work. Okay, and they are, let's go secant, cosecant, cotangent. Secant, cosecant, cotangent. We always abbreviate with 3 letters. So secant is abbreviated with secant, S-E-C. Cosecant is abbreviated like this, cosecant, not C-O-S, because then you'd confuse that with cosine. And then cotangent is like this. They are related to sine, cosine, tangent, but not the way that would be intuitive. And why math people don't do this to make it helpful for us, I don't know. I would like to connect cosecant with cosine, but I would be wrong. Cosine and secant are related. Sine and cosecant are related. So the way I always remember this, or when I first learned it, I think, okay, what do I want it to be? And it's the opposite of what I want. I want cosine and cosecant to be related, and they are not. So it's cosine and secant. And the way they're related, secant is 1 over cosine. Cosecant is 1 over sine, and cotangent is 1 over tangent. So once I've found sine, cosine, and tangent, all I have to do is flip it. And now I have cosecant, secant, cotangent. Okay, I don't have to do any more with the triangles. I just find sine, cosine, tangent with the triangles. And to find the other 3, I just have to remember which one corresponds with which and flip it. So looking at our examples, sine of A was 4/5. Sine goes with cosecant. So cosecant of A is 5/4. Sine or cosine of A is 3/5. So that means secant is 5/3. I just flip it. Tangent of A was 4/3, sorry. So cotangent of A is 3/4. So the ones you really have to find are sine, cosine, tangent when you're given the triangle. If they want the other 3, all you do is flip them and then match them with the right counterpart. So cosine goes with secant, sine goes with cosecant, which is opposite of what you want. You would like cosine and cosecant to go together. They don't. It's opposite. So cosine and secant go together, sine and cosecant go together, and then tangent, cotangent go together. Okay? So once you've found sine, cosine, tangent, all you do is flip it to find the other 3. But then just make sure they're correlated correctly. Does that make sense? So remember SOHCAHTOA. Sine is always opposite over the hypotenuse. Cosine is always adjacent over the hypotenuse. Tangent's always opposite over adjacent. If you're missing any sides or hypotenuse, solve for them using Pythagorean theorem. Make sure you have no radicals in your denominator. And then you can find sine, cosine, tangent, secant, cosecant, cotangent very easily by looking at the triangle you've created. Okay? It's not as hard as it looks, because these are new words to you that you've not seen before, and they're on the calculator. Sine, cosine, tangent are on the calculator. But it's really pretty easy once you've drawn your right triangle and you've labeled it. Just remember it's always opposite the angle or adjacent to the angle, and never opposite or adjacent is never the hypotenuse. It's just the 2 legs of the triangle. Okay? Questions on that? Tomorrow we're doing this section today. I'm going to give you another worksheet tomorrow in class to just practice this before we jump to a quiz. Okay. Let's go through the textbook check just to make sure I didn't miss any important points. Okay, so in this triangle, what would sine A be? 12 over 13. Because the missing side is 13, it's a 5, 12, 13, which is a Pythagorean triple. But if you didn't know that, you didn't remember that, you could solve for it by the Pythagorean theorem. Once you know it's 13, sine of A is opposite, which is 12, over the hypotenuse, which is 13. Cosine A here is 5 over 13, adjacent over hypotenuse. Tangent B is on this side. Tangent's opposite over adjacent, so it's 5 over 12. Does everybody see that? Sine, cosine, and tangent for an angle are fixed. They don't change. True. There were 4 videos, and one was by James Sousa, however you say it. Okay.